Hello everyone, welcome to our channel Wisdom ML. So in this video, we'll be talking about how we can build an interactive web app using Shiny in Python. Yes, you heard right, Shiny in Python. Shiny is a very popular framework, but it was available in our language only initially. But now they have recently launched its framework in Python language also. So it's a good news for all the Python developers. They can build interactive web apps using Shiny platform. And Shiny framework is popular in the sense that you don't have to worry about the UI part. You just have to uh, write certain prescribed code for the UI part, and it will be created. Okay. The second part is that you can share Shiny app on their cloud servers, even through their Shiny editor pages, and even you can also share their app uh, GitHub pages on Netflix. So there are lots of options for deployment. But in this video, we'll be talking about how we can build a early diabetes detection program using Shiny in Python language. So first of all, let's proceed towards Shiny for Python page, which is their official page. So you can see that Shiny for Python page, and it is mentioned that you can build interactive web application with the power of Python's data now. But one thing we should note that Shiny for Python is currently in alpha. It is not developed yet fully as it is matured in our language. So it may be unstable and the API may change. So don't build any production application now because it is in development phase. But I'm pretty sure that maybe in 3-4 months or maybe 6 months of time, they will make Shiny for Python also stable, and you can also build and deploy your apps in production using Shiny. So for getting started, if we click on get started, so here we have certain steps how we can do that. So we can simply uh, pip install Shiny on your terminal. But before that, you should definitely create your virtual environment. On the terminal, you should first install Shiny. Shiny create my app and run this command shiny run -reload my app app.py, and this will load your uh, Shiny page. Okay, Shiny interactive web page, and then you create your app. So it will create one basic uh, you can say basic page, Shiny page, where which you can definitely customize as per your requirement. So let me show you our app. So this is our early diabetes detection Shiny web, in which there are 10 features we have selected. So this model which we have integrated in this that modeling process we have actually demonstrated and uh, given the uh, detailed video in our previous video, that is early diabetes detection using machine learning. You can visit to our video if you have not seen that, how we can build model early diabetes detection model. The link is given in the video description. And so let's try to predict something. So we have certain variables like polyuria, polydysphia, gender, partial paresis, sudden weight loss, irritability, delayed healing, alopecia, and itching. And we can see that in all the features, almost all the features are primary variables. Yes, no. Only two values are there. Even gender, male, female is there. But we have only one numeric feature, that is age in years. So let's change the age. Maybe we should take it as 55 and put this as yes, and put this as yes, else everything will be no. And we'll keep this as female. And when you click on predict, so you can see the probability of diabetes is 78.04%. So you can test your web application, okay, with your client, or you can share your web application with your client, with your team members, so that you can validate the performance of your model on real-time data. That is the best part of these type of interactive web apps. So, so this is the app. And now, I'm just proceed to our notebook. So let me show you how we have how and what we are doing actually. So in this notebook, which I have shown you in my previous video, in this we actually used multiple machine learning models, logistic regression, random forest, and mostly logistic regression and random forest we have used. And in this, we have actually used first of all the features, and then we have used feature selection. And in feature selection, we have selected these 10 features because they are performing well based on random forest feature importance. Okay. These are the features. So that's why we have selected top 10 features from this. And you can see that for age, we are actually scaling because this is the only numeric variable. So we are scaling using min-max scalar function. But as we are using a scalar function, so we have to also keep it as a file so that we can use it in our application. And so we have to actually save it. So whatever the min-max function we have created and fit and transform, so we have to basically, because this is a fitted scalar function, so we have to save it. So using joblib, we are doing that, joblib.dump. Then we are passing min-max and we are giving the name of this scalar. Similarly, we are using logistic regression in this app and using joblib to dump it. And this is the structure of Shiny web app. So you can see that nothing is there apart from this model folder where we have our two models. One is logistic regression, one is min-max scalar. Second is our app.py file, which I will show you just after that. And we have requirements that which Python libraries will be using for building this web app. That's it. Super easy. So now we can proceed to our app. So this is our app.py page. Okay. And you can see that how small this code base is. Only 81 lines of code. Okay. So you can understand that how easily you can build this web. So before going to the code and giving the code walkthrough, I must say that we should know how to start Shiny web app. So first of all, we have to create a Conda environment. Okay, like Conda create hyphen n and your hyphen name, in your environment name. Sorry, maybe Shiny, and then your Python version, Python equal to 3. So once you click on it, it will create your environment. As you can see, everything we have done, and our environment is already activated. That is Shiny env. Now, what we have to do next is we have to install each and every requirement. Pip install -r requirements, requirements .txt. Once you click on it, everything will be installed. Just like this, everything is satisfied. So now the question is how will be running our. Okay. So now you can see it is not running because we have just closed the terminal. So for running the app, you have to write Shiny. Then you have to basically write run. Then reload. Sorry, hyphen reload. Then app.py, which is your main file. Once you click it, it will run it on the local host, that is 127.0.0 and with the port 8000. And when you click on it, it will open. So this is our so for actually create app, what you have to do is it's a very simple thing. You have to create Shiny, create, and your okay. This is your directory of your app, my underscore. So once you execute this command initially, because I have already created my app, so I'm not executing it. But in your case, if you want to see how it will run from the scratch, so you have to execute Shiny create my underscore app, and then you will see that one basic app.py page will be file will be created within the my app directory. And for running this, you have to run this shiny run hyphen hyphen reload my underscore hyphen app. Basically, you have to give the path of the app. And when you click on it, this basic app will run, and which you can definitely customize based on your requirement. So this is the installation and getting started part. So now let me move over to the code and give you the code walkthrough. So how everything is written actually, and what is the use of each and every one. So you can see that it's a very small app in which we are using machine learning for detecting diabetes based on certain features. So first of all, we have to import important functions that is app, render, UI, and reactive from Shiny. And app is basically in class we use app.run for running the app, for rendering the app. Similarly, here you have to run app, and here you have to pass your UI part on the server on which you have written your machine learning prediction code. Second thing is render. So render is common like class for rendering any page. You have to do that, and UI is the part which we can use for building interactive UI like text box, drop downs, and everything. Next important is the reactive. So reactive is basically when we go this shiny examples. If we go to shiny examples, so we have different examples how we can use everything. So let me go to reactive. So this is the reactive effect, where if you want to give anything, just see this one. So here you can see that if you okay, it's some issue happening. Yeah. So if we click on it, so whatever the value is in this slider will be given in the output. So this is the effect of button click. So button click will always come in reactivity. Okay. So that we have used in our predict function also. And we have different things like sidebars. So you can see sidebar we can create using this. In sidebar, we are declaring input function here, input details. And on the right side, we are populating the graph. Again, there is two column section which you can use. Apart from that, there are lots of things in output. You can give text output. You can give verbatim text output with some outline box. There is UI output also. Then if you want to output a plot, you can do that. Then there is a table output. If you want to give a table output, you can do that. Or you can further highlight something if you want to. Similarly, we have some inputs also text input. So for giving text input, you have to write UI.input text, and here you have to pass the actual variable, then whatever the placeholder text, and you have to write placeholder text in the text. Okay. So this text input is nothing but the header part that you can see in text input, and placeholder text, whatever you want to see, it is written in the text box. So we have used couple of things from input, couple of things from output, and layout and reactivity. So everything we have used in our app. So let's move towards our So we have used joblib for loading the model and normalizer or scalar function. Okay, then we are using pandas for converting our inter text into pandas data frame, which we will be using for predicting that particular row. And we are also importing min-max scalar because it is important for scaling. Right? Now, uh, so first of all, we are defining the model path and normalizer path. Then we are loading both the things, model and normalizers. And here there is a catch in min-max scalar or any scikit-learn based scalar function. It will give a issue of clip related issue. So that can be solved using this code. We have to pass assert is an instant normalizer min-max scalar. That is the actual scalar function. And you have to pass normalizer dot clip is equal to false. Then the issue will resolve and it will not give any error. Now comes the best part, that is the UI part. So let me write some comment. UI section starts from here. So we have only two sections. You can see this is the UI part, and this is the actual server section of model prediction. Okay. So what we are doing basically, as you can see, we are using UI.page fluid. Okay, that we this is in HTML we can call it as a container, which will contain all the elements of UI components into it. So this is our parent UI.page and under that we are passing UI.markdown. And as you can see, we are given markdown as double hash early diabetes detection shiny web app, which is showing in our app here. Sorry, early diabetes detection shiny. Okay. Now, next we have to give everything on left side. So for that, we are using UI.layout sidebar. And in sidebar, whatever we want to place, like all the input sliders and button, so we have to keep it in inside layout sidebar and UI.panel sidebar. So as you can see, we are passing different input functions. That is UI.input selector. It is a drop down, and there is one slider that is age. So only one slider, that is UI.input underscore slider. Here we are passing age in years and passing the minimum and maximum value plus one value which will be the default. So as you can see, this is our default. When you load the page, this value will be already set at here. Next, you can see all the values which are in input selector or drop down. You have to pass it in the form of dictionary. So actual value which will be go to the for prediction is 0, and the value which will be shown to us, that is sorry, that is this no and yes, it will be given as a value. So key is our main thing which we'll be using, and value is actually for showing in the UI. So like that, we have created all the UI input components. And in the last, we have passed this UI dot input action button, where we are passing btn as our variable for the button and predict function, which will be executed once we click on button. So as you can see, when we click on predict, what will happen? It will go to this server part. Okay, and here uh, we have to basically use reactive dot effect because it is a reactive effect. And next we have to pass reactive event because clicking a button is actually an event. Okay, so we have to handle that. So for handling, we have to pass alternate reactive dot event, and within that we have to pass input dot btn. So btn is our variable, and it is actually the input. So once you pass it on the server input and output, it will understand when once you click on input button. So it is an input. Now we have to write one function which will do all the processing and machine learning prediction, machine learning model prediction. So within this function, we are first creating one row data frame by doing this pd.data frame, and if you want to receive all the values for whichever values you have selected in the UI, so how to do that? You have to pass like input dot polyurea and with uh, with brackets open close. And you can see that what is this? This is basically the actual variable name of this input uh, drop down polyurea. So again, which you are seeing actually on the UI, it is this, and the actual variable which is flowing within the application for model prediction is this one. Okay, so so you have to pass actual variable input dot actual variable and then bracket. Like that, you have to pass all the variables within the list, and then you have to mention all the columns, whatever the columns you have used in your model building process. Okay, so it will create one pandas data frame. Now comes the normalization. So we have to normalize our age variable. So for doing that, what we have to do? We will be only normalizing the age variable without affecting the others. So for that, we have to mention that test set age equal to normalizer, which we have loaded, dot transform. And always remember, we have to pass transform, not fit transform, because normalizer already min max scalar we have fitted and transformed it during the model building process. So now we have to use the scalar function which already we have learned, which already the scalar function learned in the model building process. So that scaling only it will apply, not the fresh one. So we'll transform only the age variable, and then we'll doing model dot predict proba. So in sklearn we have two functions basically. Model dot predict will give you actual value 0 or 1, or predict proba will give you probability, but it will give in terms of many digit after decimal place. So we have to round it. So we are rounding by places of 2 decimal. And now for showing in the form of percentage, we are converting into string, whatever the output we have generated, plus the percentage. So this is our prediction basically, getting prediction. Now comes the output part. So for showing all this as output, we have to declare output. Okay, render.text, because we will be showing the output in the form of text. Then we have to mention that reactive.event input.btn. This we have to mention. Okay, and which will tell that once we click the event input dot button, then only we will be showing, we will be executing this function, and we will be showing the result, the pred result into the output tab. That is this. So what is this output tab? Basically, you can see here our UI is basically divided into three parts. One is the UI markdown, which is the header. Second is the layout sidebar, in which we are populating all our input components with a button. And next is our UI main panel. So for declaring or writing anything on main page, that is on the right side. Okay, that is on the right side. We have to pass under UI.panel underscore main. And within that, we are passing UI markdown and giving the heading model out. Next, for showing whatever the output we received from the model. So for that, we have to pass UI.output underscore text underscore verbatim. So output text verbatim will give the field like this. You can see this is the border and outside border and some grayish background. Okay. And within that, we have to pass the actual variable or the actual text will be uh, this is the actual function which will be executing for printing the out. And here we have also placed placeholder is equal to true. So now you can see that we are calling this function and returning the probability by mentioning whatever the prediction we have obtained in it. That is the string variable. So in the end, we have to pass app, and within app, we have to pass app underscore UI, which we have created here, and we have to pass server, which is this. So both things, when it goes into the app, it will gives the output like this, which is shown to slides. So whatever we will give here, based on some changes, it will give the real time 8.07. So there is very low probability of prediction. Why so? Because we have kept polyuria and polydisplay as new. And we know that in our model building process, these two features are very important, polydisplay and polyuria. If they are yes, then the chances of diabetes will be way too high. So I hope you understand how to build a shiny web app in Python, and it is a very easy to use code. You just have to write very small amount of code, and this type of application you can build for any use case. I hope you like our video, and the whole code which I have demonstrated will be available in the video description as a GitHub repo and as a complete write-up on our blog, that is Wisdom Unlimited. Thanks, guys. Thanks for watching our video, and stay tuned for our next video, which will be coming in the next week. Thanks, guys.